All right, I'm back. So I had to redo this problem. We had a visit from Mr. Christie. Mr. Sigalinsky popped in, and oh, hey, there
What are
he
you
is.
doing?
We're doing some math. What are you doing?
Sweet.
What are you doing?
Being
So
curious.
we are going to do this problem together. Okay, so now this is a monster of a problem. And it took me a little bit to get the grasp of everything. So let's just look at what this problem is asking. So basically, we're looking at two things. We're looking at a cylinder or a hemispherical tank, and we're actually going to compare these two. So it's a lot of steps, and what you're going to do is look at the volume and the surface area of the hemisphere and look at that ratio. Then you're going to look at the volume and surface area of the cylinder and look at that ratio. You're going to compare those two answers, really the last answer in part A, the last answer in part B, and see which one's better. Ooh, he's got it. It's like, so let's get started on this problem because I want to get it done before school starts and it could take a while. A storage tank will have a circular base of radius r and a height of r. Ooh, the height of r. R. Okay, the tank can be either cylindrical or hemispherical. Half of a sphere, that's really important. Complete parts A through Z, basically. So, first mistake we might use here, it says here's the ratio of the volume of the hemispherical tank to its surface area. So, what the first two things we actually have to do is we actually have to find the volume of the hemispherical tank, then its surface area. These two equations, those are not it. Okay, so that might be your first. That might be for your first little issue that you guys have. Okay, so what we're going to do here is we're going to look at volume. Okay, so the volume of a hemisphere, we'll just have to close that. And so here's what we're going to do. So volume is going to be equal to, yes, it's 4/3 pi r cubed. I agree with that. The book is correct, 4/3 pi r cubed. However, we don't want the whole thing. We want half of this guy. Okay, or gal, I don't know, I didn't ask. So we're going to take half of this. So your volume actually becomes 1/2 of 4/3 is 2/3. Okay, so 2/3 pi r cubed. That's our first answer. That's half of a sphere. Okay, that's hemispherical. Okay, so we go here and we type in 2/3 pi r. Missed the pi there. Hit me with the pi. Pi r cubed. And we get a good job. No, I got a fantastic this time. Now let's look at the surface area. Surface area is a little bit different formula. We know that the surface area is going to be equal to 4 pi r squared. That's going to be our answer. But however, when we look at a half of a sphere, draw that thing. Well, that's not bad. That is not bad. Okay, we have this radius, okay, r here, and it's also r here. So we know that the area of the base, the circular part, is going to be pi r squared. That's the area of the base. Okay, but we need the surface area, so we need that, plus we need that 2 pi r squared. Okay, so you get 2 pi r squared plus pi r squared, which is 3 pi r squared. Now I just want to talk to you about one little thing. So this area comes from the area of the circle right there. Now where did this come from? That's interesting. Okay, so you actually have to go back to what they give you. We know that the surface area is 4 pi r squared, right? But are we talking about the full sphere? We're not talking about the full sphere. We're actually talking about half of that, right? Divide by 2. So that's where this number comes in. So we get 3 pi r squared. 3 pi r squared. 3 pi r squared. Love it. Excelente. Okay, so now we got to keep going. So now here's where we compare. So remember, we were looking to compare the ratio. The ratio of volume of a hemisphere. So to the surface area. So we need the volume on top and the surface area on the bottom. So if you look at this, we have 2/3 pi r cubed, okay, divided by 3 pi r squared. And that, remember, was equal to the, the volume over its surface area. That's what that equals, okay? So let's look to see what number that is. It looks like it's going to be, look for 3 in the 3 pi r squared. It looks like this is our culprit, part B. And then when you simplify this out, which is really good, you can see that you're just going to be left with 2/9. 2 divided by 9, and I believe just r. Okay, so we can go back here, and if you need to simplify this up, you can. You got to, if you want to clean this up, if you didn't know. So it's 2/3. Ah, man, I hit that button again. Oh, that'll work. We can work with this right now. So 2/3 pi r cubed times, if you divide by 3, that's the same thing as multiplying by 1/3 pi r squared. Okay, and then actually some of this pi's gone. Pi becomes 1. This becomes r to the first, and that's gone. Okay. So that's how you would do that. Now we got to look at part B. So you draw a big line. That's only the first part. We repeat the process for the cylinder, and then we compare that ratio to the answer we get. Remember, so this becomes 2/9 r. Okay, so part B now. We got to look at the volume of the cylindrical tank. So I'll go over here, hit continue. And so now I need this volume. So if I look at the volume, okay, the volume is going to be equal to pi r squared h. Pi r squared h. However, now you got to go back here. Remember at the beginning, you have a radius r and a height of r. We know that h is equal to r. So then you just substitute. You have pi r squared times r. So this just becomes pi r cubed. Okay, so that's what our answer is for the volume. So we get volume. Can I hit that button? Pi r cubed. Oh, I got a well done, Mr. S. Well done indeed. So now we go to the surface area. So hopefully I haven't lost you guys. Okay, because I told you there's a lot going on here. All right, so now we look at, uh-oh, no, spinning wheel of death. Okay, good. Now we look at the surface area. So the surface area here is going to be equal to 2 pi r squared plus 2 pi rh. And it's a beautiful thing because guess what h is? H is r. So here's another substitution we use. And notice you get 2 pi r squared plus 2 pi r squared, which gives us, Mr. S,
Pardon?
2 pi r squared, and 2 pi r squared gives us
4 pi r squared.
Thank you very much. So 4 pi r squared. Now we're back to typing 4 pi r squared. Good job. Excelente. Now you write the ratio. Same thing as we did in the last problem. So you write the ratio. You had pi r cubed. Oh, I hit the button. Not the button again. Sorry. Gives you like a headache. Okay, so 4. Okay, so we have, uh-oh, spinning wheel of death. That might be bad. Okay, so 4 pi, so it's pi r cubed over 4 r pi r squared. That equals pi over 4. Or no, I'm sorry, not pi over 4, r over 4. That's an r. I'll just erase that, r over 4. Okay, so we look at the first part, pi r cubed, 4 pi r squared. Great, right here. And then you have r, oops, r divided by 4, I believe. Excellent. So now you have to compare the two. Okay, so now we're comparing basically, I want to say, Mr. S was at 2/9 r. You have 2/9 r, and you have r over 4. This was the hemisphere, and this is the cylinder. Now the last questions are going to be based on these two responses here. Okay, so let's kind of look. I don't think I need to do any more math here, so I'm going to continue on. Continue. All right, so the ratio of the cylinder is always smaller. Okay, and I believe that's always going to be larger. Okay, so we're going to go ahead and do that. Well done, because if you look at, I think down here it'll ask us the ratios. Oops. Compare the volumes of the two tanks. We're going to have a larger volume with the cylinder tank, I believe. Fantastic, and that's all based on the findings that we had. Comparing the, if you actually compare the constant part, you're going to have a larger volume. Okay, And lastly, the radius is the measurement that determines the volume. So then you can answer these last questions. And they come up from comparing. Comparing the constant part of each ratio shows that the cylindrical tank will have a larger volume. So the constant part, 1/4 and 2/9, okay? Compare the volumes of the two tanks. So if you look at the volumes of the two tanks, okay, the volumes here, the volume was pi r cubed versus I think 2/3 pi r cubed. So this is much larger. Okay, this is the cylinder, and this would be the hemisphere. So 2/3 pi r cubed is less than pi r cubed. So that's how we know the volume will be larger with the cylindrical tank, not the hemispherical tank. Okay, so that's what these mean here. They're comparing some of the answers. Compare the volumes. Compare the ratios. Okay, the ratios, 2/9 to 1/4 are the cylindrical tank is in favor there. 1/4 large versus 2/9. Mr. Mungai. All right. So if you guys have any questions or comments, feel free to email me, and we'll see you next time. And still recording.